This is a second video looking at finding the rules for arithmetic progressions by finding the nth term of each sequence. I've put the link to the previous video in the description below. I began the previous video by looking at multiplication tables and spotted a pattern between the multiplication tables and the nth term. So for the 1 times table, the nth term was n. For the 2 times table, the nth term was 2n. For the 3 times table, the nth term was 3n, and so on. We could then use this information to find the nth term for other arithmetic progressions. So for example, if we take the sequence 1, 3, 5, 7, 9, 11, 13, we notice that to get to the next number in the sequence, you add 2 each time. And so by using the 2 times table, we can find the nth term of this sequence by drawing a relationship between the terms of the 2 times table and the terms of the sequence. So for this example, we can generate the terms of the sequence by subtracting 1 from the terms in the 2 times table. And so the nth term to this sequence is 2n subtract 1. Here are some other arithmetic progressions that are linked to the 2 times table. Notice that for each sequence, the difference between the terms is plus 2. And notice that for each nth term, it contains 2n, which of course links to the 2 times table up here. What I'm briefly going to do in this video is look at sequences where the next term in that sequence is getting smaller. Again, we're going to use the multiplication tables. Have a look at these sequences. If we look at the top sequence, instead of having 2, 4, 6, 8, 10, 12, 14, and so on, which would be the 2 times table, we have -2, -4, -6, -8, -10, and so on. So instead of having our nth term of 2n, which is what it would be if it was the 2 times table, our nth term is going to be -2n. And notice that to get from one term to another, you're subtracting 2 each time. Similarly, if we look at the next sequence, we have the 3 times table except all the numbers are negative. So the nth term is going to be -3n. And notice that to get from one term to another, we are subtracting 3. And if we look at this sequence here, we've got -4, -8, -12, -16, -20. And this is the 4 times table, except each term in the sequence is negative. So our nth term, instead of being 4n, will be -4n. So we're going to use this information to find similar arithmetic progressions. And this works exactly the same way as we did in the previous video. Have a look at this sequence. We can see that in each case, we are subtracting 2 each time to get to the next term of the sequence. So I'm thinking of this sequence here, which is the -2 times table. So we know that the nth term is going to have -2n in it. We now need to look at how do we get from this sequence, our -2 times table, to this sequence. Looking at the first term, to get from -2 to -1, we have to add 1. Looking at the second term, to get from -4 to -3, we have to add 1. Looking at the next term, to get from -6 to -5, we have to add 1. So it looks like we're having to add 1 each time to get from this sequence to this sequence. So for our nth term, this is going to be -2n add 1. And if we look at this sequence again, to get from each term, we are subtracting 2 each time. So I'm thinking of this sequence here. So we know that our nth term is going to have -2n in it. And if we compare the terms of both sequences, looking at the first term, to get from -2 to -4, we're subtracting 2. To get from -4 to -6, again, we're subtracting 2. And to get from negative 6 to negative 8, we are subtracting 2. So we appear to be subtracting 2 each time. And so our nth term is going to be negative 2n subtract 2. Here are 2 more sequences. I'm going to find the nth term for each sequence, but you might like to try and find the nth term for these 2 sequences yourself. So pause the video and have a go, and then press play when you are ready. So looking at the first of these 2 sequences, we can see that we are subtracting 3 each time. So I'm thinking of this sequence here, the negative 3 times table. So we know that our nth term is going to have negative 3n in it. Now let's compare the terms. Looking at the first term, to get from negative 3 to negative 4, I subtract 1. To get from negative 6 to negative 7, I subtract 1. To get from negative 9 to negative 10, I subtract 1. So this means that our nth term is negative 3n subtract 1. And for this sequence here, this time we are subtracting 5 each time to get to the next term. So I'm thinking of this sequence here, the negative 5 times table. So this means that the nth term for our sequence is going to have negative 5n in it. We're now going to compare the terms of both sequences. Looking at the first term, to get from negative 5 to negative 2, we're going to add 3. Looking at the second term, to get from negative 10 to negative 7, we're going to add 3. To get from negative 15 to negative 12, we're going to add 3. So for our nth term, it's going to be negative 5n add 3. Here's one more for you to try. So pause the video, have a go, and when you're ready, press play. So for this sequence, negative 5, negative 12, negative 19, negative 26, we can see that we are subtracting 7 each time. So I'm thinking of our negative 7 times table. So our nth term is going to have negative 7n in it. We'll now compare the sequences term by term. So to get from negative 7 to negative 5, we're going to add 2. For the next term, to get from negative 14 to negative 12, I'm going to add 2. For the next term, to get from negative 21 to negative 19, we're going to add 2. So for our nth term, we're going to have negative 7n add 2. So that's all I'm going to be doing on these kinds of sequences. But I'm going to be continuing with sequences in the next video. But I hope you found this helpful. Don't forget to like and subscribe, and thank you for watching.